Class has started though. Recording starts. So I was able to go through your assignment for those that submitted, and I gave my feedback. So, and it's entirely good, you guys, you are leveraging on those skills and you are making use of it, and it's really very encouraging. So we keep it up and we keep moving. And that is it. I think it was a Mag I told that she made a mistake, in one of the approach that she was using. But for Blessing, I think your is positive throughout. Am I correct? Blessing.
Yes, but I have one question. No, maybe when you
Okay.
finish with this thing.
Okay. Then for Izaku had light issue. She just submitted her own today, so I could not go through it to pass the comment. But all the same is good. Average, you guys are leveraging on it, and I'm happy. So keep pushing like that, and we keep going forward. So let me start to share my screen. Oh, Blessing, you want to ask the question so that I can show Ezeaku and Mag the error. You want to ask the question?
Yes, okay, let me ask.
All right, go
So
ahead.
when I was doing the work, I decided to use two different encoders, like one hot and label, just to see if there will be any difference. But I noticed that when I used one hot and after fitting, when I wanted to fit it again, the thing was now giving me error.
Okay. Part of the Mag I gave to you that you're going to explain the robust scalar that you use. That why did you use that?
I saw it on the internet. Maybe I told you. I was
No,
looking for
I
nominalizer, be
I
nominal.
told you. I said you are going to explain to class, not me. Now, why am I interested in that? Is that even if you are seeing anything in the internet on the internet, it is normal for you to dig deep to understand why and why do you have to use what you use. There is no problem you trying to explore a new, which is very good, honestly speaking, but don't just use anything you see. You understand? So you should know the brain or intuition around why you are, so that if they ask, I've told you this, I said, as a data scientist, nobody is like telling you this is what you should do. As long as you can justify why you did what you did, which is at least conforming to standard, you are okay. Do you understand? Now I've told you that thing before. So even if you're using robust scale or anything that you find, there's no problem about it. What are we looking for is that can you justify it? Does this method or techniques you are using, does it follow the nature of your data set? Like, is it in line with the type of data you have? Does it address a particular? So if you can justify those two things or thereabouts, you are good. So why I said you need to explain is I expect that when I send that message, you go back and go and dig more to read more on it and say, okay, maybe this one or two things that I was able to find out. And I know when I was using, I didn't think about it, but when the question came, I went back to check so that you can know about it. Do you understand the idea now? So, and that is how you're going to be learning, in this phase. So anything you are doing, don't just do it because you want to do it. Try to understand why are you doing what you are doing. Do you understand the idea? So, which is very, very good. It will cement your knowledge
All
and
right.
it will bring more information about that thing. So the method you use is okay. The robust scalar is fine. There's no problem about it. I just wanted to dig more so that you can explain and understand what they are used for. Because not everything works for, like, it's not a go-to process, like everything work for everything. No. Each of those
All right.
techniques has their peculiarities. They have advantages, they also have disadvantages. Do you understand? And at times they also have their use cases. Like, you can only use it at when we encounter this and this. So you should know those stuff. So that's that. So it's actually good. It's good. So for let me start with Mag. So I want to start sharing my screen. So just confirm you can see my screen now, so that I'll be sure. Let me know if you can see my screen.
I can see it.
All right, thank you. So can you still see?
Yes.
Yes, I can see.
All right, so let me try and open mag assignment. This should be mag. Yeah. So mag, this is where I said there is a mistake. Now when you are converting those three lines, the assignment I gave you was try to play around each of the transformers, like use scalar, use minimax, use normalizer at each of those transformer that you use. Try to completely like build your model, score it, that is evaluate that model, look at what it is. So when you use ordinary minimax, what did they give you? When you use normalizer, what did they give you? So then an asset combine the three together. That means use standard scalar. The output of standard scalar will be the input of the minimax. The output of the minimax will be the input of the normalizer. And when you're done with those things, also build a model and see the performance as well. So, and all these 4 steps, which is going to be 4 different scalar, minimax, normalizer, then the combination of the three will be 4 different techniques that you have adopted. Comment on your result. What did you observe? So that was the assignment I gave you. So when I was going through mag, I saw that that's at the point when you are trying to combine the theory together. You supply wrong input.
Sorry, me too. When I was trying to combine the three, it did not work.
It
You
will work.
say you said continuous error, continuous data, waiting. I just uncommented it and continue my life.
Okay.
So
No
it did
problem.
not work.
Okay, no problem. But it will work. You will see.
Maybe because it's the robot scalar I used or with.
No, it's not. It's not an issue. I know all of these things about your input. What are you supplying into it?
I
And that was
supplied
what.
the output of the previous scalar. That's what I did. I
Okay.
was supplying the output of the transform of the previous scalar. I did not put the same value. Like the
So
result
which
I
is
got from min max will be the one I'll
okay.
use for Jenny.
Okay. Which is why it is also important for you to now go ahead and see the documentation of that transformer. If you have gone to check the documentation, maybe his own input will not be like an array. Do you understand? Or something in that nature? That could have informed you on what to do. Do
True,
you
sir.
understand the idea now?
Yeah.
At times it's also like that. So that was why I said it is important for you to always be sure as to what you want to do. So Mag, hope you can still see my screen.
Yes, I can see it.
So this is your numCAD target here. From here, numCAD target, everything together. And I wanted to, okay, now using normalization, each of them here. Now, when you combine the three together, concatenating data set, okay, normalize, full normalized value, blah, 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 video, then full, this, yeah, from here now, this is where the error is coming from. Look at it from this place. You have already gotten these 3 data frame, yes, which is good. So you use standard scalar on it. Are you with me? So your final output on standard scalar is this, right or wrong? This is the output
Right,
of the standard scalar.
right.
So this output should be the input of the next transformer you want to use. So which is what you did when you are using minimax. You see that that is the input, which is correct. So the final output of your minimax is this, yes or no?
Yes.
So when you are doing normalizer, why did you now put numdf? Do you see it?
Oh, that's true.
So immediately I said, okay, of course, this will work because you don't know, because this one is the
Yes,
normal data.
that
This one works because it's a
scalar
normal data.
max.
This will have been scalar minima should have been the input. Then you run it, okay?
Yes, I just noticed I should have used that scalar in min max. Oh,
Minima,
almost.
yeah. So Then why did you use, what does this norm L2 means? Can you explain? Did you go back to did it or did you check it? What does it mean?
Hey. No, I don't like. I'm an upcoming.
No. Upcoming does not. This one is internet information. The same thing I told them, blessing. If you check internet, you see it. If you check I've told you this thing that remember to always check documentation. Remember, so it's still there. If you go out to check your documentation, you will see there. So it's not like maybe you are upcoming or you are pro. They are internet information. Okay. So this L2 is called regularization. Okay. What do I call it?
Regularization.
Yeah. Is an hyperparameter tuning object. What you are telling us is that just like, well, let me use this simple approach. If I ask you to solve a quadratic problem in elementary mathematics, at least everybody knows that. Let's assume that generally we have three methods. Is that you use the formula method, is that you use the factorization method, or you use the completing the square. Do you remember? Do you
Small.
remember?
Yes.
At
Yes.
least, at
Yes,
least
yes.
one.
It's
So,
the almighty formula.
but it's not. There's not like almighty formula. Just the formula method. Or quadratic formula method. So the one that we are saying, okay, almighty formula in quotes. So now what you are saying is, for that simple question, you can solve it by three different ways, right? So each of those ways, they are the technique you want to follow. By the end of the day, you will get a result. But the approach you follow when you're using formula method is not going to be the same approach you're going to follow when you're using quadratic and when you're using factorization. And obviously, it's not going to be the same thing when you use completing the square. So what you are saying is, oh, I want to normalize this data set, but use regularization factor of L2. You understand? Which we call the Euclidean space, that is in mathematics. So use L2. So by the algorithm, it has been designed to say, okay, when you specify the technique to use, the algorithm has been designed to know what to do. Just like, you understand, like when you said, oh, I want to use formula method. You that use formula method, you might end up spending maybe 2 minutes. Someone that want to use complete the square, because that one takes a lot of steps. That person might end up spending like 10 minutes. But at the end of the day, both of you get your answer, except maybe somebody make a mistake in that regard. So this is what all of this thing is talking about. There are more. It's not only L2 that we have. We have L1. You understand? So, but what we call them is regularization. They are part of the hyper parameter tuning. You understand? Which you are going to get to. So you know them. So that's why you check the documentation for any algorithm or any method you want to, you will see all of these things defined. So the only problem we always encounter is, when do I use it? How do I know that this is the right thing to use? You understand? But they are there. So by default, even if you not state it, by default, it has been designed to use a default of any of the parameters that is available. So even if you did not state, it will pick the default. But if you state, you are imposing that, Oga, use L2. Maybe what is right for your data is L1. But because you saw it and you just go and copy L2, so you will use the L2 techniques on your data because you have imposed. But if you don't impose, you use general one. But if at a particular point in time, you notice that the type of data you have will not work very well with L1. You can now say, let me use L2 based on what I have. So that in that regard, you are imposing that, Oga, don't go and use anyone for me. This is what you should use. And that's what you did here. You initialize, say, use L2 for me. And it's okay. But the only thing is that you don't know why is L2. Are you getting it now? Do you understand that? Is it clear?
Yes. Yes,
Uh-huh.
it's clear.
So that's it. So that's about that. So, but you get to see more of these things when you get to hyperparameter tuning, just for you to know. So I think that was the only issue I saw. And then what you have just done here is you have mismanaged the operation here, because here you did normalization for the normal data. Do you understand? And you are combining it with the one that you did scalar and minimax. which is not a problem. You get the idea. So, but anyways, I just need to point that out. Is that clear now? That was the only error I saw your data. Is it?
Yes, it's clear.
Yeah. So
Yes.
a minute, please. Um, so hello.
Hi.
Hi.
Sorry, I had a call. So that's just the observation that I noticed, and in all, you guys did well. So the observation that you can see, even from the little exercise you did, though it might not be significant, but you agree with me that each of the evaluation by each method you use is not really the same thing. They might be little, it might not be significant. Are you getting? But the numbers are not the same thing at the end of the day. Do you observe that? Like, are you there?
Yes, I'm here.
Like what Mag wrote now. When she used minima, she got 0.997. That's like 99%, right? So when she used standard scalar, she got 0.996. Though at this stage, it's not really too much, but what we can establish is there is a difference. Are you getting my point? So why she got
Yes.
0.996 for normalization might be because she used the original norm data. Are you getting the idea? So
Oh,
all these
yeah.
can we can look into. You get the idea, but though at this stage it might not look like there's no really different, but these are things you need to take note of. So each of them behaves differently depending on
Yeah.
what what your data really is. So at
Yes.
times, combine the three if that is what you think you can do to optimize your model. Because at times, when you use ordinary standard scalar, maybe your accuracy might be around 70. But when you're trying to combine the three, so that what you're trying to do is that I'm not leaving anything on, I'm not leaving any stone unturned. I want to ensure that everything is fine and no, there will not be any point whereby this data will hide into. So by the time you combine the three together, the performance can get to 90. And that means you have improved it from 70 to 90 just by doing the right transformation. Do you understand? So at times it works. So that was why I asked you to try that exercise. Is that okay?
Yes, it is. It's because of the minor slight difference. That's why if not, I would have stopped at 0.99. But if I stopped at 0.99, everything will be the same. So that's why I added the
Yeah,
third number.
yeah, 3 decimal place. That's good. That's good. That's where you even do approximation. Percentage will be 99 point something, 99.2, 99.21. That's how you because you have if you have to convert this to percent, each of this one is 99.7%, one is 99.6%. They're not the same thing now. If you have to assign position to it, someone that had 99.7 will be first, and that one 99.6 will be second. Okay? Yes or no?
Yeah,
Mhm.
yes, that's true.
So,
But
any other question?
me, my own, I was getting, using the normalizer, I was getting 54%.
Okay, you see, that's another one. Just that I didn't have your own
And
to check your notebook.
yeah,
Did you
but I
get
was
you?
using the original norm data for all of them. Oh. Maybe I don't know, maybe I didn't
Oh,
understand the question.
maybe you did. Yeah, the same mistake. I pointed out here. Is that what you are saying? You're using this one, the original data, instead of the output of each of them.
Yes,
Oh,
yes.
okay, of course, of course.
So,
So,
and my this thing, standard scalar gave me the highest 0.99, then min max gave 95, 0.95, then
mm.
normalizer gave 54.
54. Okay. So but when we now come back, okay, good. I look at another discrepancy now that Asia brought out now. Let me check the normalizer for mag. I think this is the ordinary normalizer. Yeah, this is her own normalizer. Yeah, look at what she got here. She got 99.6 ordinary normalizer. But you got 54. So that means something is wrong. Also, Blessing also got 90 something. So I don't know why you get 54, even when you use ordinary normalizer. Are you with me? Okay. Two things
Yes,
can be
yes.
responsible. Maybe the model. She used random forest. What did you use?
Logistic.
That's it. Can you see I want you guys to be relating with it now. Uh, Mag used random forest. She was able to get high performance. But Ezeaku used logistic regression on normalizer. She got 54% on the same data. You can see also model also matters. Can you see the difference now? So when she used logistic regression for standard scalar, her accuracy was very high. But when she got to using that same model for normalizer, the score was very low. So you can see the trick. All these things is what I want you to see, understand that anything you are doing, your model evaluation depends on so many things. Depends on the data, depends on the algorithm that you started with, which is the model, depending on the parameters that you have inside the algorithm. So it's not just picking it. In fact, it depends on the process you have underwent before you get to building the model. Are you getting the idea now? So you see the way we are playing around it. So if you have to judge now between logistics and random forest, you can say that random forest is doing well compared to logistics. I don't know if you're getting the idea. You see the way it is. So which is going to lead us to part of the exercise assignment that's compulsory. I'm going to explain it towards the end of the class that we're going to be doing, that we'll submit next week, and we'll take it forward as well. So you need to understand all these little things. I told you this class is not, we're not building, what we are doing is for you to understand what you are doing and why you are doing what you are doing. In terms of the model, you understand why am I using this? Why is this one very important? why is this model behaving normal, better for me at this stage? So if the two of you, if Ezeaku and Mark now, and even I think even Blessing also use random forest. If we have to submit this um, results on the table now, all of you have done the same step. All of you have built a model, but on the normalizer, if that's the method we are trying to adopt, we can see that random forest is behaving very, very well compared to logistic regression. So somebody who tends to take MAG or Blessings model to work with, because performance of 99 cannot be the same thing as performance of 54. Do you get the idea? So these are things we need to check. And it's important because these are the knowledge we are going to be seeing. Apart from I just want to pick model, I want to understand why am I doing what I'm doing. And these are key. So thank you, Ezeaku, for that. It's good that we have discrepancies. It's good that we are using different models for you to see the possibilities of what we have. Is that okay? Is that okay?
Yes, it is.
Now, another thing I observe in MAG work is MAG, you are not consistent with your seed. You define seed of 10 in the previous one, and after that, you are defining, this is it. You started with 10, you're going to go and be defining 15. There should be consistency. Because what we are saying is, all these things, as minute as they cause a change in the performance of the model. And that's why I'm placing emphasis on it. When you were doing your whatever, you define it as 10. That is I've explained that SIP to you. So that data is already picking that 10, and that's what you want to be working with so that you can have consistency, you can have reproducibility. You can get the same result every time you run it. But in the course of going forward, we are now defining seed of 15. At this point, you have alternate the behavior of what the 10 gave you with what 15 is giving you. I don't know if you're getting the logic.
Yes,
Mhm.
I'm getting it.
So these are things you need to be consistent of. If you have chosen 10 and you want to use the same information on many models, be consistent. What you are doing is 10 is what I've picked to, and all across the model I've built, you can build 50 algorithms. It doesn't matter. But for all the model I've defined or I've built, I maintain the same seed. So that at any time they run that report, they're going to be getting the same thing. Not 15 up, 10 down, 5 below. You can also do what we call research, which I'm going to teach you on seed, that you can define so many seed, maybe 10, 15, 20, and a model will run through each of those seed we have defined at once using loop, and it will pick the best out of those ones. And those are things we are going to be doing. So it's not difficult. But yeah, what we are doing at this stage is not to manually define it, which is what you did now. But when you even manually define it, be consistent throughout so that you don't have jumping results. One is behaving well at C10, the other one is behaving low at C15 on the same model. There's always a problem. Do you understand the idea now? Is it clear?
Yes,
So
yes, it's clear.
those are the two things. So when you are defining it manually at this stage, be consistent. In fact, if you can define at the upper part of your notebook, no problem. My seed is 50. So anyway, I'm using seed in this notebook is 50, and it's not changing. So everything will be reproducible. You get the same result every time you run that notebook. Okay? All right.
Yes,
So
thank you.
yeah, let's move ahead. So I think those are the corrections. So Ezeaku, I will still go through your notebook after in the course of maybe the week. I'll reply you if there's any observation I made. But this is just the general overview of what you guys have done. Okay? Any question?
None from me.
All right. So we start. Okay. So as of last week, what we're able to do is introducing us to different ways in which you can treat multiple or many missing value in our data sets, because it's not going to be ideal if it's so much that is speaking about 50% of our data set and we just go and drop it, that means we completely remove it. We will have caused biasness to the data. That data will no longer be what you can use to work around a good model. Not that you're not going to build model with it, you build model with it, but that model might not represent some things that you have taken out, which is expected. So in so doing, we try to devise a methodology to see that we have learned how to build model. So can we relate with some of the simple skills that you have learned in selecting data sets and trying to play around it, build a model that we can now use it to predict the missing value that we are looking for, and we did it. So we build the model, we predict the missing value from the other data set that we have splitted. Then at the end of the day, we're able to put everything together to become a new data. So this new data, which we call full DF, is your original data set. Original, that means this is like what was initially given to us that we loaded from the beginning. The only difference is that this one now has no missing value again, because this was the region where we have our missing value. It was the flood that was missing. But at the end of the day, we've been able to take out all those things that were error in our data. So this data now is as good as complete, clean. So this data now, we have not really solved the problem. What was the problem? The problem is to build a model that can predict flood. But in the course of doing it, we encounter something that we have tried to manipulate. So we have not really solved the initial problem. So the next thing is now to build a model using the original data set. So everything you have learned also will come into place. The only thing is that you are likely to skip some things because you are so sure that this data does not contain missing value again. I don't need to do missing value. You are so sure that it does not contain duplicate again. So because this one has been removed, but you can still check them to see. But we are certain that it will not have missing value. It should not have duplicate, and if it is not having that, okay, what is the next thing? Pick X, pick Y, and build your model, and that's all. Again, so that you can get a new model that is capable of predicting the occurrence of flood, given all other parameters in this data set. So that is what we said we should do, and we did it, which is very good. So hope is clear.
Yes, it is.
Yes.
Yeah. So today class. Um, Today is 21st, right? If I'm not mistaken. Am I correct?
Yes,
Hello?
today is first.
Okay. So this is so I'm going to call on the data that we have, full DF. This is our data. So now we want to really solve the problem, which is building a model that can predict the flood. Two things I will also bring in addition today is for you to see concept of data imbalance. Okay. Now, all of you have built the model, so I'm not going to build the model. Okay. Again, you have built it regardless of logistic, whatever. So I'm going to start with the concept of the data imbalance for you to see it. So we'll follow the method. Then we'll now go and build the model again when we have corrected the imbalance and see the performance and see the difference between what you built and when we corrected an error. I don't know if you're getting the idea. Are you following me?
Yes, it's very clear.
Yeah. So now today's topic will simply goes to we are building model, so I don't want to repeat ourselves. So all of you got the steps. So we need to identification of imbalance in the data set. So what does this thing mean? Now, all of us, at least on average, when we build this model, the one we give as an assignment, at least the highest we had, we can see that we're having some like 99%. To you, you can think that that model is doing well. And honestly speaking, it's doing well because if a model is at 99, that means that model is doing well. But the problem is doing well on what? That is the question. Is doing well on the prediction of my flood. Now, what is this prediction of this flood? Flood is the target. You remember? So the next thing you're going to do is if I run something here, which I'm going to start with, foodf dot flood dot value count. Before that, let me do unique before value count. Unique. Now, my flood, which is my target, contains two values, right? It contains 1 and has 0. Are we getting it? Which is good. In this case, we mean by 1, that is a yes or true. 0 means no or false. That means when it is 1, that means there is flood. 0 means there's no flood based on this data. Now, you have now built this model, and your model is performing at 99%, which is good. So that means that if you want to interpret it, what you are saying is that my model is capable of making a prediction at 99% accurate, which is good. But the question they will ask you is, okay, which of these two inputs that you're looking at is your model going to be seeing more? Like, I'm trying to build your intuition around what we call data imbalance. Yes, it's capable of predicting 1 and 0. Now, the question they will ask you is that, are you sure that this your model is not biased at looking at one of these outputs or the two? And your intention normally should be that any model you build should be able to predict the outcomes of your target variables equally. Get that concept? You should be able to predict any of the labels in your target equally, no biasness. That means if it's giving 90% to 1, you just will give 90% to 0. So, but you might not know because your model is 99, you just want to fly. But you need to check, is there imbalance in my data set? If that is the case, how do I check it? Now, for me to check the imbalance, it's just for you to call it, and always is you are only interested in the what? In the target, but that's where you are going. Anything apart from target, you don't really need to bother yourself about maybe there's imbalance or not. But on the target, because that is your goal. So you want to be sure that the data set is balanced in a way that between the labels I have, there were no biasness. Now, how do we check it? So we have seen what we have. So checking for imbalance in the data, we will see now. So if I use the common method of foodf dot flood dot value count. You know what value count does? Value count will tell you total number of each of the labels you have in your column. So the column is flood. I want to see how many. We have seen that there are 2 items in the column. So I want to see how many ones and how many zeros, which are my label, right? If I run this, can you see now? The output is telling me that 1 is about 20,148. Y is 0 is about 396. From this output, can you say that this data is balanced?
No.
Okay, you see the problem now? No. Fine, we have built a model, but what you are saying is, if that model is exposed to external data, there's always biasness because it's going to be seeing more of 1 than 0. Do you agree?
Yeah.
So it's like you built a model. It's like you built a model that is only seeing one thing because 20,000 will overwhelm any 396. In fact, it will get to a point by the 396 will not even exist. It's going to be seeing 396 as 1. I don't know if you're getting it. So I don't know if you're getting the idea.
Yeah.
So at every point, your model will be telling you there's flood, even when there's no flood. Why is because there was or there exists an imbalance in the target data that you did not take note of. You have built a model, yes, fantastic, beautiful, but your model is biased towards one of the label. And what is biased to? Is biased to 0 and make a good friend with 1. So what it simply means is that if you expose that model outside and they give you an external data set, and that data set should have been no, that means there was no rainfall. I mean, there was no flood. At the end of the day, if you use that same model you have built, the answer will give you to what will be telling you that there is flood. Why? Is because what you have built is only seeing there is flood. Do you understand the concept now? How
Yes.
good. So therefore, if that is the case, we then need to extend our thinking to what are the types of how do we correct imbalance. So I told you last class, I said when you build this model, they have seen the problem already that there will be problem, though you might have a very good performance. Can you mute? You might have a very good performance in terms of your accuracy, but it might not be a true representation, and that's what has happened now. There were good performances in the model, but it was not a good representation because there were imbalance in the data set. So there are so many strategies we can use to correct our imbalance. As time will permit, we will explore few. I'm going to see the way it is being done. So we have established that there is an imbalance. There is data imbalance in the target variables, and hence we would need to correct this anomaly for us to have a robust model that truly represents the behavior
FL WhatsApp audio.
the behavior of the behavior in the data. So that is what we're going to do. So I'm going to rush and list. So this is what is important. So, and this is one of the concepts that we have not explored. So these are things you will check. Even after you have done your cleaning, you have done blah, 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 everything is fine. What it simply means is don't jump to build a model. Go to the target, check, especially for classification. Because don't forget that this is a classification problem. If it's regression, you won't know. Why? Is because regression is just continuous variable, so you cannot know which one. So when you do value, it's going to give you all the numbers, which is not. So in regression problem, you really do not have this problem of imbalance. But whenever it is classification, okay, there is need for you to check for imbalance in data sets. Are you with me now? So this is very, very important. Even if the labels are 50, for as long that is the label you want to predict, and it's a classification problem, therefore, check for imbalance. So immediately you see it, just apply imbalance method from that point, then get the new data that is already corrected. You now use the new data that's corrected to build your model. So your model is okay. Do you understand? So move to strategies.
Yes.
Yeah. Strategies for correcting data imbalance. Yeah. So number one. Have you seen this concept before? Has anyone come across it?
No.
Okay. So number one, we have undersampling. Number two, we have oversampling. Number three, we have smoothing, which we have smoothing, we have I think let's talk about these two first, then before we combine it, so that you don't, so you can focus. Let me list everything out. When I list it, then we'll pick them one by one. Then we have the smooth. Then we have the smooth four. We have the smooth. ENN. So I think this four should be enough. Okay. So smooth means synthetic minority, synthetic minority, synthetic minority over sampling, over sampling technique. Yeah. So why smooth ENN? It will be all of this. Control C, Control V. So you can tell me the ENN then. You can tell me the ENN. Hello. Hello.
We are here.
So you can tell me the ENN.
Edited nearest neighbor.
Neighbors, yeah. So anything you see in your, so just know this. Just like I removed the K, you remember K now. So the only thing I expect not to even know is the E. You understand? But NN in algorithm, KNN, ENN, so it's always nearest neighbor kind of, okay, except for convolutional network when you have RNN, CNN. So which is another meaning. But anyway, let's see these four, okay, and see how we make use of them. Each of them has advantage and disadvantages as well. So you no one is like 100%. What do I mean by that? Like there's no one that will give you what you need. So you just have to trade. There will be a trade-off depending on what you are looking for. Okay. So and you need to know each of their behavior so that when you're using undersampling, you know why you want to use undersampling. You know what are going to be your trade-off for all other ones. If you're using oversampling, you know already what is going to be your trade-off. Do you understand? So these are very important. So we will start with the undersampling and see what we are saying. So for the undersampling, the concept here is not too much, just like the way it is sounded, undersampling. So what it's going to do is that you will focus more on the lower class. So from this explanation we made now, you already know that 0 is one that is not much. You get it now? So when you're using undersampling, what you're saying is focus on the lower class. So when you build the algorithm for the undersampling, his own focus will be on the lower class. That means it's going to reduce the total number that you have, which is around 20,000, to become a replica of 396. I should have 20,000 plus data. But if I'm using undersampling, I want to use the minimum of my class as a representation of the entire data set. That means I want to use 396 as against 20,000. From what I've taught you before, what do you think is going to be a problem if I'm using this undersampling? At least, can anyone try? Can anyone try?
The
Hello?
model.
Is that?
Won't the model to be biased? Since it's
I don't even want us to talk about biasness now. Based on what I've taught you, I want to use 396 against 20,000. What do you think has happened?
He did not learn enough.
It's
He's just small
it will not learn enough. Number one. What other thing? There is this particular thing I'm looking now for.
imbalance.
Is that what?
Imbalance.
No. It will have been balanced. What it's saying is it's going to be using this 396 for both 1 and 0. So imbalance has already been corrected. Okay, but instead of you having 20,000, what you're going to be having, the sample you're going to be having now will be 396. That
It's
the
not
data
broad.
is not broad. Yes, that is one.
So learn just more.
You learn
When
to,
you
yes.
expose to a larger set of data, it will do rubbish. I don't know.
Yeah, it's good. No, don't say you do not know. You have explained. Don't say you have. That's the explanation. What the implication here is that, fine, that data is already balanced, but it's balanced on a fewer samples. That was the same thing I explained when we're trying to replace NaN under flood. You could have removed everything and just build the model with, But I told you that the implication is that you are not giving the data, the model, to learn a lot of things. Those ones you remove is a behavior, because each of them is a data point. It's a behavior that could have informed your model, but you have removed it. In the same way, you have compressed 20,000 to become 396. What you have done to that model is to say, I have limited you. Just learn what you can see within 396, which is actually talking from the point of only the zero, which was the problem in this case. Do you understand? So indirectly, the model will not have enough information as to behavior. Do you get it now? But another beautiful thing about it is it will perform faster, because imagine, is it the time that a model will take to run 20,000? Is it going to be the same time it will use to run 396? No, right?
No.
So 396 can be around 1 minute, while 20,000 can be like 20 minutes. And time is also of importance. How fast is your model? This one will give us a faster model that will fast because it's not learning anything. But the implication is that you have lost some valuable information. Is that clear? Is that clear?
Yes.
Yeah.
So you have lost valuable information. So this is the trade-off. So if your interest is to say, you know what, let's assume that your interest is to even know maybe there is no flood. So I can decide to take away flood away, because if there is flood, I already know that one as an obvious case. If my problem is addressing no flood, that is what I want to really focus on. We've already known that between so months in the year, the flood will always happen. But that one is like an obvious case. But I'm not interested in the obvious case. I'm interested in the case that is not obvious. So in this case, the not obvious case will be 396. So undersampling will be better, because what it means that my target is also lying on the no. So if I do undersampling, it will only focus the no, and my model will be better. Do you understand the trade-off now? Can you see the way I'm explaining it?
I don't understand this last thing you said.
I said trade-off. I mute your mic. Trade-off means which one can I let go? Which one can I accept? We have established that if you use undersampling, some information will be lost because you are reducing bigger value to smaller value. Just look at it in that regard. Some things will be lost. Okay, no problem. Two, we have said that it will be faster. It is computationally efficient. That means the model will be faster to run. It will not take much time because it's just very fewer samples. Having said these two properties, what does it mean when you want to use it? The only time you can use it is, say, let's say, for example, when they gave you this problem, they said, our problem is that we have always been having difficulties in knowing the time that there will not be rain or there will not be flood. Look at the objective of the problem. Their interest is to know period that or instances that there are no flood. So already what that one tells is that they already certain that at some certain time or conditions, there is always flood. They already know the existence of flood, but they were unable to know when there will not be flood. So maybe that's why they want to put the operation, so that we know what all those periods do. Let's go and be doing our road construction again. But they were unable to determine that because of the problem they had at hand. They now call you as a data scientist, and they said, okay, at least for January, February, March, we're already certain that there will always be flood, as an example. So that means they already know that between these 3 months, they will always have flood. So flood, which is a yes, which is a true in this case, is not their problem. Their major problem lies on when there will not be flood, which they don't know. So if I want to build this data and I have imbalance, I can focus on the no flood, because that's the interest of the model. So that when I do a trade-off in terms of the imbalance, I can leverage on the no flood label, which means I will undersample, so that undersample will only focus on the no flood. And when I build the model, the model will have learned when there is no flood. And when I give it to them and they supply the data, it will just give them, because that is the concept I want my data set to be seeing, or I want my model to be learning from. Is that okay? Is that okay?
Yes, yes.
And so that is
Yes.
so that's why you need to know what is the objective of this problem? What do I want to address? What is this business owner? What does he want me to do for him or her? You understand? So by the time you are doing your own method, you have considered all of these things and you are also putting them into use. So that is it. Because they said they are only interested in knowing when there will not be flood. So already if you get to this point, you can do undersampling. When you do undersampling, your model will only, in fact, it will learn more of the no flood, whatever, and it's going to be okay for them, and they are okay. But some case they will tell you that they want to know the two. So if they want to know the two, you cannot use undersampling, because if you do undersampling, one side will be suffering, while the other one will be fine. So these are things you have to learn or know, and that's what I explained. Is the undersampling okay now? Are you okay with it?
Yes, it
Okay.
is.
So note that. So undersampling. So we start with the process. I've explained the trade-off, I've explained the advantages and the disadvantages. So you will get that from the recording. So how do we go about it? So in doing it, there's some library we need to import. There is a library that we need to import. Even if you don't have it, just import it on your notebook and you're going to be fine. And the library is called Imbalance Learn, just like your sklearn. So its own library is Imbalance Learn. So we're going to do pip install. In case you don't have it, pip install Imbalance, which I'm very sure none of you will not have it. So just run this on your notebook at the point where you want to use it. Look at what I wrote. Exclamation pip install Imbalance Learn. So this is the library we use to correct the data imbalance. Every method I've mentioned, they are inside it. So there's no way you want to do imbalance without not installing this library. Is that okay? So because anything you are going to be doing on all these four I've written and so many other ones, they are inside here. So just like your normal sklearn. So if I run this now, and when you're running it, your internet must have internet too. So it's saying for me requirement already, because I have it, but in case you don't have it, in fact, which I'm very sure you're not going to have, so run it. So once you run it, it's okay. Okay? Do you understand that first step? That's what you need to do first. Do you understand
Yes.
that? So you need to install the library using the pip install, and the name is Imbalanced Learn, just like your sklearn. Okay, so we need to import the library now. Okay, so the next thing is we import the library. Since you have installed it, so let's bring it on board. So importing the library is from Imbalance Learn. That's what we learn. Imbalance Learn, short form. Imbalance Learn. Look at it. For imbalance, then learn is learn, just like sklearn. Okay, imbalance learn dot. What strategy you want to use underscore sample. Okay, that is the method we are dealing with. The import random undersampler. Voila. So that's the method you want to use. Look at what I did. You do your installation. Then from this library, which is your Imbalance Learn, is Imbalance Learn. That's the short form. Okay. Are we together? Then
Yes.
this is the method you want to use, undersample. So this thing follow the same thing. So if it's oversample, it's going to be oversampling. So import random sampler. So this is your method that you will use that has that on the sampling method. So random is just there because we want to select the sample randomly. We don't want it to be fixed, like, you understand? I've explained randomized for you. So random on the sampler is just saying that I'm going to use on the sampling method, but I want the sample to be picked randomly. That's why you are including this. Okay. So random sampler, random on the sampler. All the first letters are capital letter. I think you remember that. R is capital, U is capital, S is capital. So this, if I run this, you see, so I have imported randoms undersampler. So my random undersampler is like, it's not like your standard scalar. Okay, so and you know by now that when we have it, we initialize, we do those ones, which is normal, right? So the same way you are doing your standard scalar and minimax is the same approach. Okay, so hope you are getting what we are doing.
Yes.
Yes.
All right, good. So that is okay, at least for this random undersampler. The next thing is, what data set are we really dealing with? Don't forget our data set is our full DF. That's our original data set. Are we getting it now? So this original data set that we have, we then need to do some, don't forget that when we are doing the same thing on our data, on our fixed standard scalar, we will select features, we select targets, yes or no? So you're still going to do the same thing here. Select your features, select your targets so that your model knows what it's doing. Okay? Are we following?
Yes.
All right, good.
Yes.
So let's select that. So we're going to select our features because we're going to need it in the before you initialize. So select your features and target. And I know that this one is no longer a problem. Target from your data set. So I made the clean data set. This data set we are talking about now is already clean. Don't forget. You cannot come to this approach if you have not fully cleaned your data to this level that is pure. Okay. So I'm so bold to be using this at this thing because my data is already clean. So if it's not clean, it means the first step is for you to go and clean all this thing we did, clean everything up to where you get to where we are. So for me to select, I think let me just go and call the column that we have already been numerical column, cat column, just select numerical and targets, features and targets. So for me to get it, for it to be easier, I'm going to do full underscore df dot columns. So if I list it out, list all these things for me. So I know this is my target. So let me put features. Features will be full df, full underscore df, and I copy everything. Control C, and I put them here. Control V. Hope you understood what we did. Any problem?
No, no problem.
So I don't expect anything here. All right, so I do my target now. Full underscore df. So my target will be flood, right? Yes or yes?
Yes.
So my target is this. So we pick that, we are good. So this is so I've already separated it. So that at this stage, I don't have any problem. I've gotten my features and I've gotten my target. So let's now go and initialize our random undersampler initialization. So initialize the undersampling strategy. All right. So now also define your seed here so that you can be consistent around it, right? So let me define the seed. Anything you want to use. I'm using seed of, let's say 20 is my choice. You can use anything. Just define my seed so that I don't need to be repeating it. So anytime I want to use seed, you already know that I define as 20, just like what I've told you. So let me call the initialization as under sample. Okay, so that this is the initialization, and that we do it for our standard scalar. We'll call the technique. Remember, Control C, then put it here. Then we'll do this. Remember this. This is how you do our standard scalar. Yes or no? Yes or no?
Yes.
So let's define some little parameter in it. as the default because we are using undersampling. So we want to define, don't forget we have defined the seed. So we will do our sampling strategy here is it should be auto sampling strategy. These are also auto hyperparameters I've told you. Sampling strategy. We are telling strategy. Yeah. It should be auto. That means it's automatic. You don't want to disturb yourself by any. There are other parameters, but these are like the default. So your random state, random underscore state is equals to seed. So by now you know what it means. So your seed is 20. So if I do this under sampler sample, if I run this, I want to see what it is. So you see, this is like the standard scalar that we have initialized. So what did I do? This is just initializing. So I just decide to do sampling strategy to be automatic, and my random state will be seed. That means just 20 of the bucket. Don't forget for what I need. So I have initialized my random sampler on the random sampler. Do you have any question at this stage? Do you have any question at this
I
stage?
don't.
Is it clear? It's not like the way
Yes,
you did
it's
your
clear.
standard scalar. So when we do standard scalar, what do we then do? We fit now, Abi. We fit to transform. So now we do.
Yes.
So in this case, you don't fit and transform. You just do one fit and you are okay. Okay. So in that regard, the next thing is for us to send in our features and target that we have split. So that what you are saying is I'm giving this model the entire data. You will be able to select, to randomly select what you are looking for because you have initialized a random sampler in it. So the next thing is for me to do my data split, therefore, data split according to the under sampling method. Okay, so if I do this, I can now have my new X and my new Y. Because don't forget that we need it. X and Y is what you will need when you're building your model. So your X and Y is your features and targets. So I've already initially defined my features and from the original data. So in this case now, I will need feature that is coming from undersampling and target that is coming from undersampling. Are we getting it? Are you following?
Yes.
I'm going to have X fit for under, so it means for undersampling. Y, I can also use feature and target. I just want to, Y is target for under. So, because I will need the two. Do you understand? Is equals to, this is my model name, under sample. Copy this. Then dot fit underscore resample. That's all you do. That's all. Then pass in your features and your targets. When we are doing standard scalar, we just first of all say scalar.fit, then a new model name, a new data frame name, then data and scalar.transform. You understand? So the same thing we are doing here, but in this case, we don't do fit and transform. What we just do is fit underscore resample. Okay? And you are using the model name. This is like the model name on the sample. Is it clear? Is it clear?
Yes, it is.
So we now pass
Yes.
our features and target, which is what you have done here, features and target. So that what you are trying to do is I want to get a new features and a new target, which is different from the original one. And I call it X feature under. That means this is the features that I obtained by my undersampling. And also this will be the target that I obtained from my undersampling, which is different from the original one. But we need the original input. That was why we did the first splitting. Is it clear? Is it clear?
Yes, it is.
So features, I copy this, put it here, features, comma, target. So immediately you do this, you have splitted it. The new data now is now a sampling method that we have adopted, which is to correct our imbalance, and we have adopted the undersampling strategy. Okay, so immediately I run this, my data is splitted. So X feature and Y target, they are now my new X and Y. Okay, are we following what we are doing?
Yes.
Good. So you can decide to see this X feature. If I copy this, if I paste it here, can you see they are still your futures? Do you see? Are we following?
Yes.
So your target, please don't, it's not difficult. Your target is still your, can you see still your target? Anything different?
No.
So, but what can you see? The only thing is that number of rows has changed. There are 792 rows now, and they are what? For the futures and for the targets. As against what was the original data? Initially, it was 20,000 plus.
20,000.
20,000.
Again, you see the
500
idea.
or something.
Are you getting the logic now? Are we following?
Yes.
Yes.
So it has reduced 20,000 to 700, but that is what it is. So you can see that it was working towards the lower class, which is the 0, because if 0 is 392 and you have a sample that now has 792, so it's towards moving towards the lower class. That's what it's saying. That's the strategy. Do you get it now? Do you get
Yes.
it?
Ola, please,
Yeah. Yeah.
this our white target under, can we
Mhm.
do dot unique to know how many now at this point are 0 and how many are 1?
Yes, you can do it now. Let's do it now. And we want to show you the graph. We'll do it. You see. Control C. I want to show you I'm about plotting the graph. Oh, okay. But don't forget here is okay, let's see unique. Or let's do value count now. I doubt this because it's not coming from the original data set. But let's see. Yep. Do you see?
Wow. Yeah.
Yeah.
Okay.
Nice.
I want to, if I upload the graph for you, upload the histogram for you, see it now. Okay.
Yes.
So that's what I told you. Which value is he assuming? He assumed the lowest value. So which means that this data now has been corrected towards the focusing on the lower case, which is the no. If that is how your data looks like. So you can see that this method is biased towards the higher number, but it's a friend to the lower number now. If you build your model, what you are saying is that this model will see more of no. Okay, you understand. So that's what it means, but there's no problem. I've corrected it. It's different from when I don't even need all the ones that was 10,000 plus in the first place. So if I build my model now, it's randomly, though it will have picked some of, you can see that he selected 0, 396 and selected 1. So when you build this model, it will see them equally, just that your focus was more on the no. Do you understand? That was why you downgrade the data to the no label. Do you understand? But when he did the selection, he balanced it. That means I'm having equal number of no and equal number of yes. If I build this model, I will be able to just see the two. The only thing is that small sample was taken, 396. Is that clear? Is it clear?
Yes.
Is it clear?
Oui, c'est clair.
It's clear. Okay. So let me quickly let me plot let's plot the histogram. Can we do that?
Yes, we,
Oh, yeah, give me the code to plot the histogram. So you can see
no,
the
yeah, enjoy your style.
which time. Give me the code to plot the histogram. Say, did you not do visualization? You see this madam. Okay, we have to know how do we import our matplot? I think it's PLT we use. PLT library, yeah, PLT. So an SB for Sibon. Okay, let's see the visualization. PLT dot figure figure. Which figure size should you use?
10 by
Figures.
Uvu.
What's the width and what's the height? We should use 10 by what?
Okay.
10 by
10.
10 by 10. Okay, that's what Blessing said. Though. That's it. So then you plot PLT dot histogram. You pass the Data inside. What's your data? I only want to see the target. This is my interest. I want to see. My interest is this Y. That's what I want to see. Voila. Then comma, maybe beans to range. Let your range is 2. Let your range from 3. Align. You should
Wait,
align
oh,
towards the
Ola,
left.
sorry, oh.
Yeah, I'm with you. Towards the
Did you
left.
have all these things?
Towards the left. These are things that you
It's
will.
not the things that you see every project you do you used to use
It's not
graph
every project now.
and surgeon and everything.
You know
You
there
don't
is there's documentation of all of these things. So you might even keep it, you might leave it, but just for let me finish this. So once you do one, you can always copy and be pasting it in another one. It's not difficult. Okay. There should be a color, just like what you are thinking. Like I want to plot graph. What should I want to see in the graph? I choose. Let me choose blue color. So these things I'm doing. All this one, you might not put it. I just want to let
but it
the
makes the graph look beautiful.
yeah.
Can be fine and appealing to the eye.
My alpha is 0.7. So then you can put the title. What's the title? Title is a string. So what do you want to the histogram of give us title. Histogram. Yeah, now histogram for the sample class. For sample class
Yes.
using undersampling. It's just a title. It's not you need the label. Yeah, plt dot x label. You need the label. What's the label? Your x is what? The x is always the target because it's the target I'm interested in. It's the target. That's what I plotted. So that's my main goal. Then you need the y label. Get the y label. What's my y label? That's the value. That will be the value of your of the class. So let's call it number of occurrences for the sampled data. So after the label, because I want it to mark so that I can see. Okay, let's see what it's going to look like for PLT dot show. Something is missing, but let's see what's going to look like. If I plot this, if I run this, you see. Now I'm going to show you. What can you see? I have two Instagram, right? Right?
Yes. Yes.
This is my target. Look at the way my target is. My target is still in form of numbers, but that's not my target. My target should be 0 and 1. So I need to format this x-axis in a way that you can see 0 and 1 instead of doing what I have. And 0 and 1 should be range of what? 0 and 1 should be range of what?
1.
Is 0 and 1. What range will I put it? If you don't tell me that, I will not do that one. Is that
0 and 1 is
Uh-huh.
1.
what is the range? If I want to get 0 and 1, which range will I do? No,
Isn't
now.
that range of 1? It should be start from 0 and end.
I forgot what's range.
Range is
The
within.
highest minus lowest.
No, that's mathematics. What's range in Python? I think give me a range of 5. What are the numbers you should see?
0 to 4.
Okay.
Oh, you see you.
Is that
As
what
I'm
you're
asking
asking?
okay. That's what I'm asking you now. All of you, I told that this thing you know it often. You are forgotten. Bless me, you have used to eat akpu.
It's a range of 5. I told you 0 to 4.
But when I was asking you that I needed 2, 0 and 1, what's the range? You are saying 1. The range should be 2 so that I can have 0 and 1. The range should be 2, yeah. Then
You are thinking many things.
I'm doing what?
I said we are thinking many things.
Okay. Now I understand. Let me say we have let's use true. No, false and true. Okay. It's balanced now, okay?
Yes.
So you can see that by pictorial, you can see that they are balanced. This is balanced. If you have plotted it initially, it won't have been like this, okay? If you have plotted the before we collected it, Control C. Let me go and see. Let me show you the plot here. Let me put the plot here for you to see. If I put the plot here and I change this one to target alone, not going to be example.
Yes, please mute your mic.
Sorry, Jerry.
Original class. Number for calling for the class for the data, for example for the data. If I want this, can you see the initial thing you have? This was the initial. When we splitted it like original, you can see that it was not, even from this graph, you can see that this thing is not balanced. Do you see now?
Yes.
But when we do the resampling method, by doing the method of resampling and undersampling method, is it balanced now?
Yes.
So that's what you do. Okay. Any question at this stage? So with this one, you have done. You have been able to finish your resampling. Okay. Hello.
Yeah.
All right. So what's next? What's then the next step? What's your next step?
Then you now start doing your you now separate that feature zone into numerical and categorical. I mean, which are the top?
Yeah, you are correct. That yourself. Beautiful. That's very good. So already this step is very okay now. At least if this is what you want to adopt now, the next thing is that you now have your X, which is your feature, and you have your target now. But you now know that okay, for these features, there are still numerical, there's still categorical. I will now do the method of is this standard scale I want to use, blah blah blah. You do all those guys down. You get the idea now, and you now go and do your split, blah blah blah, and are done. Okay?
Question no.
Yeah, we are with you.
So does
Yeah.
this resampling? It's not you don't need to do and describe all those things again.
What did I say? I said before you get to this step, you will have done all this wahala. You know where you are. You have described, you have info, you have checked missing value, you will have corrected the data. Like your data is
So you
already
didn't
clean.
do it now. So me, I just thought that this is the method that wants to just get clicking.
I didn't get you, sir. What do you say, ma?
Ma, I'm a woman.
Yeah, what
I'm
do you
not.
say? I've corrected myself. I said I didn't get you, ma. What did you say?
I said that I was thinking that you do it later.
Which one? What am I going to do later?
The describe and all those things you need to do before this.
No, I told you before we move here. Don't forget that we are coming from somewhere. This is where we started today. We have assumed that at this stage, this data is already clean. All of us agree. You know, from this stage, this was the assignment we did. I don't want to repeat myself and say, okay, let me build model. We have gotten to this stage in our last class, right? And you have used it to build a model. Yes or no? Which is okay.
Yes.
So before you even build the model, which you'll have done describe, you have done those things. You have done your processing, all those voila, you'll have done it. So it's at the point of building the model. And that's okay. If I go and jump, let me check if this target is having problem. So when you check, when I say, Oga, this target is having a problem. So if I use it to go and build this model like this, I will just be biased. So can I correct my balance, data imbalance? The answer is yes. We now quickly move into that method, which is what we are doing. So one of the approaches we have exploit the undersampling. So when we do the undersampling now, this data now is now fully balanced based on our undersampling strategy. So if it's balanced, I now have new features and targets, and you can now begin use that one to be working into your selecting categorical, selecting numerical, code, transform, all this wahala that you will do. And at the end of the day, you do train test split, you build your model, pim, and you're done. Okay?
Ola, please, I
Okay.
have to say something here.
Oh, I'm with you.
In this in this particular data, it had none, right? So we had to
Which none?
build it. No, before the
Yeah,
original data,
yeah.
it had none, right?
Yeah.
So we had to build a model to predict the none, right?
Yeah. Those
Now
are
it was
training.
after predicting the none that we are now doing this balancing and all that.
Yeah.
So
Those
if there
ones.
was no
Okay. If there was no.
if there was no none in the
Yeah.
data at all,
Mm,
so we
mm.
just go straight to building a model. The
No,
essence of
no. You don't go to build a model. You check if the target is balanced, kind of. If not,
okay,
then you
yes,
do
okay,
this.
okay.
So the model we built to predict the model, to predict the non initially, they are the pre-processing cleaning method. It's just a cleaning process. But what did we do when we are building the model in that first stuff we did? Is to also correct missing value. Is missing value not part of the method you will follow when you are cleaning your data set?
Yes,
So what
yes.
we all this model we built to predict non was a way to correct our missing value. We don't want to remove the column. We now use a strategy to build a model that can predict that stuff. And it predicted it for us, and we created a new data frame without the missing value. So already we have corrected the missing value. So imagine if it's not much. Let's assume the missing value in the target is just 5. We will not go through the process of building a model. We just use drop and to take all those nonsense away, and we find our data. Do you understand? I will go. I will continue with the next one. Do you understand the idea now?
Yes.
So
Yes.
that's why we go through that process, and I thought that skill is handy. It's useful anytime, any day. You understand? I've not seen it in any textbook, honestly. So it is key. So you have got something now that you are holding. Immediately your data is more than 50%. Don't go and remove. It's not the best idea. So people will get stuck. What can we then do? Do you understand? So one of the strategies I can build a model that will predict this nonsense I'm looking for. Then I use my whatever, and I'm good to go. You get the idea? Aha.
Sorry,
Okay.
Bill, I'm
Yes.
still confused.
I can't hear you, blessing.
I'm still confused.
Which confused again?
At what
Yeah.
point are you supposed to do this resampling?
Jesus Christ. Blessing, that means you have not been following us. So
I'm here.
what was the assignment we gave
The way
you?
she will understand. It's
What did
how
you
I
do?
understand though.
What did you do on this assignment?
You said we should use it to build model.
Did you build the model? Did you
Yes.
build the model? Good.
Yes.
That is what you are known to do, right? So I introduce you to more advanced way of doing the right thing. I've explained that okay, the model you built, fine, is good, but I've explained why that model is biased towards one side. And how do I know? The next thing you need to do is okay, this data is already clean. I don't have missing value, I don't have duplicate, everything is fine. Can I go ahead and build the model? The answer is yes. But before you jump to build the model, check in your target data, target column. Is this target having imbalance in it? If there is imbalance, you come to this step that we have done. If there's no imbalance, you move ahead to build your model just like the assignment you have done, and you are good. But if there's imbalance, which you will see here, that oh, thank God I know that there's a method that we call imbalance. If I didn't know this, I would have just do the correction and build the model the way you guys have done it, which is okay. But that is not representing the true nature of your data. So the next thing I need to do, if I jump to, so that's another advance you have learned now. You don't just jump to build model even after your data is clean. Check if the target value or the target column is having imbalance or not. If there's imbalance in it, you need to quickly correct that imbalance. And process of correcting this imbalance is what we started today. One of the strategy is undersampling. So all this thing we are doing now is the undersampling method of correcting imbalance in the data. And we have just gotten to this stage of our data imbalance. And we have seen it initially and after we corrected it. Do you understand now?
Yes.
So that is what you need to do. So the thing you have learned from that is different from what you know before is that even if I have been able to clean my data, I want to clean it up to the point of the data is now fully clean, I want to go to modeling. Before you jump to modeling, check. You see another thing. Check if the target column, especially if it's classification, I've told you, if it's regression, you don't need this imbalance. But if it's classification problem, you check. Okay, it's classification. No, let me just go and jump into the model. Let me see if there is imbalance in my data set. If there's imbalance, you now begin to see which method works for you. Is it undersampling? Is it oversampling? Is it smooth? Is it smooth ENN? And any other one that we have available. So one of the method we are doing today is undersampling method of correcting imbalance. Is it clear now? Is it clear?
Yes. Thank you, sir.
All right. So you now, after today's class now, the advance you have learned is you can now check for imbalance and you can correct it before. So somebody that they have not learned this step will just go and build the model, which is what you have done as an assignment. So, but that is not because your model is 99, yes, but your 99 is only seeing 1, it's not seeing 0. So you have built a model that is biased already, but you don't know because I will not give you that information. And I told that even this you have built to is only seeing only one label, which is your 1, which is the true in this case. That's what it's saying. But that's not the intention. You'll be able to see the two equally. So in advancing our methodology or strategy in understanding this concept critically is to say, okay, is there imbalance? And we saw that there is imbalance. The next thing we want to correct it. So any question at that point?
No.
Blessing, are we good?
Yes, I'm good.
All right, good. So I hope you understand it now. Okay.
Yes.
So going forward, we now have our target. We have our what's it called? So let me call this the data I need now. I need this, my feature. So if you want, which I'm going to show you, you can concatenate this one to become one data so that you don't need to be struggling again. You have extracted what you needed. I can concatenate this one together so that we have new. So if you want to make it easier, you can say, okay, I've been able to select the data I wanted. So I can concatenate now so that you now get a new data set that is simply for under. Okay, so I can say, okay, you know what? Let me concatenate the data set now. At least to know that this one I'm doing for undersample. This data is only for undersampling. So you can concatenate, you can call it maybe data df under, okay, and that will be pd dot concat this guy comma this guy axis equals to 1. So df under. Do you see now? At least, so you see your new data now, which is the data set only for under. Are you getting the idea now? If you want, so that okay, what you're going to be working with now is just df under. You can now select your features. You now know what you now to do now. Are you getting my analogy? Is it clear, Blessing?
Yes.
Is it
Yes.
still in class?
Yes.
Is it clear now? Sure, you understand what we're doing now. No, at this stage now, this data is already clean, so it's already fine. So I can now go ahead and select my features, categorical, numeric, all those things. You can do it. Do you understand the idea now? Are we good?
Yes.
Okay, let's
We are
quickly build
good.
this model. So that we'll end it here. So let's finish this. So now follow our process. What's our process? Select numerical, select categorical, select target. Abi? Yes or yes?
Yes.
Mhm. So select numerical. I'm going to write it in one line, no, in one kernel. Select numerical, select categorical, and target as 1. So numerical will be num data.
Ola, please, I want to ask a question.
Yeah, go ahead. I'm with you, mom.
Please don't be angry.
Why do you say that?
See,
Abba.
no, it's a simple question.
It's not nothing. No
You
question
know,
is stupid. I'm with you.
you know that our original data,
Mm.
if there was no none in it at all, maybe it came complete.
Mm.
That initial model that we built to predict the none, we wouldn't have done that. We would have just gone straight to this imbalancing this thing, Abi.
Yes.
Okay.
Just imagine there's no that drama, but see, in reality, that's what you will see. So don't put your mind on it will come clean. No, no, data will not come clean. So data will not come clean. So you always, the only thing is that it might not need us going through the process we went through. It might just be literally 2 missing value, maybe 5, maybe 10. Those one does not need you to build anybody. Just remove it or use strategy of me. There's so many things you can adopt. You get it now to correct the missing value. Once you correct the missing value, data is clean. You've correct the missing value. If you remove duplicate, everything is fine. So data is already clean. The next thing is to be model. That's okay. If I jump to be model, let me see. Let me check if there's this imbalance. If there's imbalance, you quickly correct it. It should give you a new data frame. Data frame is now what you're going to be working with to do scalar, do your something and video model. Is it clear now?
Thank you. Yes, very clear. Thank you very much.
You're welcome. I didn't hear Izaku. Is Izaku still in this class or she has left us with our wala? I think we have left us with our wala, with our own wala. What did you say?
I said I'm here. I'm battling with sleep. It's coming out.
Yeah. You see, when I said she has left off the wala, she said I'm not right now. So she's okay. That is my. Those are my medical categorical only is just station names. Hope you will agree. Station name is only the categorical.
Yes.
I put them here. And my target is just only float. So I've already selected what I needed. So target, everything is fine. So if I want this code down, I should be fine. So num data we have, cat data we have, target data we have. What are those things we now do? We now do scalar. If it's scalar you want to do, if it's minimal you want to do, if it's normalized, and if it's the thing you want to do, usually what you are practicing in your assignment. Okay, so let's just do the simple one of that scalar, standard scalar. Okay, do you agree? Oh,
yes.
Okay. Let me do the normalizer for you. You guys didn't. I think some people are saying they have
Yes,
normalizer.
please.
So let's do
Yeah, the
normalizer.
name is normalizer. Like,
Let's do the normalizer to transform. Transform. Okay. So numerical data. You initialize. Yeah, tell us the library from
sklen
dot dot hey
preprocessing.
preprocessing import mag.
No.
you wrote 2I in your pre-processing.
It will tell me error now.
And so he did it intentionally. He's like, he used to like that bug.
So from SQL end of preprocessing import normalizer. That's it. That's normalizer. Okay.
Yes.
So if I run this, if it's there, we tell us. You see that it has run. That's normalizer. So
it.
we will now initialize it. Is that what we do? We initialize it. No problem. Control C. Come here. Put it here. Close it. Norm it. Normalizer is okay. Okay. You see that we have initialized it. So if you initialize it, you just put fit and transform. So without not wasting time, I'm going to do it straight because I want it to be, we have to upgrade our game now, right? Yes. So what do we do?
Norm
I want to
is
do
equal
fit transform. Fit transform straight. Okay, yeah.
to be fit underscore transform
What I
or
want to what's going to be the variable name?
norm
Norm equals
normalizer.
Okay, so you're correct. So let's say we call it norm data equals norm, which is the normalizer, dot fit underscore transform
Then in bracket the
in bracket,
this thing.
which is norm data.
Yes.
Hope we don't have any problem around this. And my norm data therefore is this. Okay, you see it?
Yes. Yes.
Remember this. So are we good? We'll do what's going to be the next thing. Can we
Very
do
good.
this one now or we should wait later? What are you going to do here? You can tell us.
Change it to DF.
God bless you, blessing. Change it to DF if you want. Okay. Are we together?
Yes.
So how do we change to
Yes.
DF?
You
So
say
norm
norm data is
frame.
equal.
PD dot data frame. All this issue you should be eating it in your mouth. Data frame norm data, right? Then columns equals
Yes.
copy all the columns. But we didn't define for this. Remember, I'll just copy this guy. Voila. Ezeaku. Eze.
Sir,
Okay. I don't want to be close. Data. Okay, we got that. Normalize. Okay. Is it looking beautiful?
Yes.
So we have normalized, and you see that the index is correct. I told you if it's normalized, if it's all these scalar minimals normalized, the index is always correct. You don't need to reset index under numerical transformation. You remember that in last week? Remember?
Yes. Yes.
So we have done numerical. We do categorical now, Abi. One not encoding. Oya, tell me the library. Encode categorical. Tell me the library. Exactly. Tell me the library. Want to encode categorical data. Easy.
sir,
Easy. No one like you. Oh yeah.
SKLN
SKLN. Is that where you're starting from?
from from SKLN.
Yes. We are moving from SKLN to where?
Pre-processing.
Dot processing. Then followed by
Import one hot encoder.
good. One not encode like this, Abi.
So capital letter 0.
Is there?
Capital 0.
And capital E and capital E.
E.
Good. What did he say? What was wrong? Blessing didn't see this one.
I
Blessing,
did.
you didn't see this one.
I did not see it. So you are doing it on purpose.
Blessing, you didn't see this one. Yeah, I wanted to see it now, but you didn't see it. So we'll do our initialization, one auth. Okay. Code this. Put it here. So we initialize it now. So convert. I'm going to do it at once as well. Cat data equals one not dot fit dot transform, right? The data is cat data. Cat data. See it here. Cat data. Okay. That's the categorical. cat data, and after that, I will reset cat data equals cat data dot reset index to drop equals true. Voila. So if I want my cat data now, anyone have any issue around there?
No.
What was the issue? What did he say?
It does not have reset index.
Which one
It's
now?
like that the thing gave you matrix. Wait.
Don't worry, let me comment this one out. One not
Array that you returned.
okay. What is it?
What's part of this coding? I don't used to like this part.
So she doesn't really like. You like it now? What's there? Okay. Initializing.
Oh, it's true.
Oh yeah. Pandas.
What's happening? No. Yes, where did you select our cat data? Yeah. So let me call this cat data here first to see. Maybe it's an array at this point. Okay, at this point is okay. So let me go and see the card data. Before running it, cards, let's call data. I have to run this again. Cards data. Where is it? What rubbish is not saying? Then one not encoder transform. He has a drank tea before. Okay, we are done. We've transformed it. Okay.
Yes.
So let's reset the index. Let's remove this. He drank tea before. Mark, serve this stuff tea. So
As if the team knows that it's tea I drank this night.
so you see, you know what we are talking about. Card data. So our card data now will have been reset. Okay, which is good. So the next is the target, right? Blessing.
Yes, sir.
So the next thing is the target. You agree?
Yes. Oh, I did not know.
You did not know. Or you did not know. You heard what you said. So target is tag data. So we only reset that one. Tag data equals tag data dot reset.
I thought we already reset the target before.
We didn't reset it. I will show you.
Okay.
drop equals to 2. Look at the tag data. Target. We did not do anything on target. This is the point of selection. Where is it? Do you see? We only selected at this place. We did not. Can you see?
Okay. Yeah.
There's no way.
Yes.
We did the selection. We were taking them one by one. We did numerical. We did categorical. Now we are on target. See clear?
Oui,
Please.
c'est clair.
See here. So for you to see that we have not done it, tag underscore data. So see that we have not done it. Okay. So if you reset
Okay,
now,
yes.
is it Aku? So it's reset now.
Sir?
Okay, good. I just want to be sure you have
Yes.
not slept. So we've done the transformation of the numerical, we've done the transformation of the categorical, then we have reset all the index and also target. So what next now? What
We
next?
concatenate.
So that I can have at least a complete transform data if you want, right? So conca.
Yes.
Okay, should I put everything together for you? Should I concatenate everything together for you?
Yes.
Or okay.
Yes.
I'm thinking of just doing only the futures. Then you just, because you're still going to need the targets on the long run. Do you understand what I'm doing?
No, I don't understand what
Okay,
you
okay.
said.
No. Yes.
Okay, let me use transform GF. ed.concat. All these concat now, you should be sleeping and they wake you up. Bang, you should tell them because you have used more than enough time. Abibeko, num data, cat data,
And
tag,
data.
and axis is equal to 0, Abi. Axis is equal to 0.
1.
Blessing.
Axis is equal to 1.
Okay. I thought you have forgotten.
1.
Is that?
No, I did not forget.
Control C. So, you see everything. Bye-bye. So we have 49 columns now. So therefore, I can do train test split, right? Train test. You still have to do selection distance. That's what I was saying. Okay. Are we good? Are we good? You're not answering me again. No?
Yes.
So,
Yes, we are good. Oh,
dot drop.
I don't know.
The
Can
column
you hear me?
Yeah, I can hear you.
Okay.
Dot minus on the axis equals to 1. Then your charge. Yeah, just use X and Y so that you move away from all this switch on X and Y. Reduce. You understand what I did now? Blessing. Blessing.
Yes.
Do you understand what I did here? This was what I was explaining to you. When you say what other way can we use to select? I don't want to use dot values now. You should know by now.
Oh, okay.
You know, if you have to be dot values, I would have just done this one dot values. Remember this dot values.
Yes.
Then do -1. You remember these ones now?
Yes.
Do you remember? So I'm teaching you other ways. Okay.
Yes. You're telling me to
No,
pick everything apart from flood in the first one.
apart from floors. So if we are to use our
Then
dot
the second
values,
one, pick only flood.
pick only floor. This,
This
if you want
one
to use
is
our dot
clean.
values, we'll have just used this one as dot values, and you select your X and Y. You remember?
It's clean. That one.
What did you say?
I said this one is cleaner.
Which one is not cleaner?
That other one, be writing dot 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 dot.
Okay. They play. Yeah, from want to import plain text from Mag.
Please, I'm coming.
Don't come.
It's not supposed to be in array.
That's what I told you now. If you want to use array, you will have been this one, the values. Well, this is another method. It should be your array is just to select your X and Y. I've told you now. I'm teaching you another way. Blessing has this question in the assignments. That's what I'm explaining this method. Normally, we will just do this one, the value. Then you select your -1, those things, to give you X and Y. Is that not? But is it clear? Is it clear?
It's clear.
Oh, yeah.
It's clear.
Nag. Yeah, tell us the library.
Okay.
Mag
Hey,
is
what
not
did
here.
you say? Sorry.
Tell us the
I was trying
library.
to
We want to do
train test split.
Tell us the library.
From sklearn dot model selection. Ew.
Continue now. I'm with you. I'm doing another thing, so it's not.
Import train
it's not
test
wrong.
split.
I just want to show you this one. So I'm not going to run it so that you see that this one is what Blessing said. Can it come? It's long. It's cleaner.
I did not say it's long. I said this second one is cleaner. You don't have to write
Cleaner.
it.
Yeah, I said you said it's cleaner.
But tom. Just in English, straight.
Straight, right?
I mean, oh my god. But seriously, this thing can be boring.
All right.
I don't know. It's not boring.
So Blessing, Mark, what did you say from sklearn?
Did you not forget? I thought you would have forgotten that it's me you called.
Why would I forget that is it I call from sklearn dot?
Model selection. Import train test split.
Eziaku. Eze.
She's sleeping, oh.
Oh yeah, are we good? Look at this thing. Listen, are we good?
Yes.
You are already sleeping.
Yes, I think so.
Are we good?
Yes.
All of you said yes. So in your own model selection, it's always capital T and capital S. Okay.
Why is it
small
like
letter?
Mr. Ola? Train test with small letter.
So we'll do our X train at this point. X test Y train on Y test, right? Equals to train test split. Train test split. X is your X, Y is your Y. Test size is what?
0.2.
0.1. And you should know Y
Yeah.
is 0.1. Why?
Yes.
Why? Don't say yes.
No,
Why?
now you told us what you told us the last time. You said it will test some and it will select the one that it will use to train.
Yeah, why don't I use 0.2? That's what I'm asking you.
Because the
That's
data set is small, so
Clap for
we
yourself,
don't.
example. Clap for yourself, example. Because data set is small. Data set is just 792. So if you use 20%, you know you are taking around what's 20% of 792? So example, one coffee for you. So that you not sleep.
Okay, I'll be expecting.
Be expecting. So Mark, the reason is I told you last time this choice of 0.0 whatever is a function of how many data you have. We only have 792. If you do 20% of this is like around what? What's 20% of 792? Exactly.
140 something or 150 something.
Mm-hmm. So it's around 158. Okay. So that's like much out of 700. So and you want it to learn more because this test is nothing. The test data is nothing. You just need to test. So I want data to learn. I want the model to learn as much as what it can learn. So therefore, just use if you can use 0.001, there's no problem. Okay, because it's nothing. Okay.
Yes.
All right. Good.
Yes.
So we have done the whatever. So which model do you want us to use? So from this our assignment, we have agreed that random forest is good.
SVM.
Abi?
Okay.
No, let's random. I think we consider random forest is good now. Shivi, we can see that now.
Yes.
So let's do random forest from sklearn dot blessing dot what? We want to import our model blessing.
yes.
We want to use random forest.
Improving from SKLN dot models. Abi, is it model
Model
based? Yeah.
for random forest.
I don't know.
You know, if you don't know, that's where we end the class. So
Ah,
all of you, it's blessing that make us to end the class.
no.
Then tell us.
From SKLN dot assemble.
Yeah, you say you don't know.
I had to quickly Google it though. I don't know it.
And you have been building model.
Ah,
So sklearn dot.
promo the thing, so it's the one
You
that
have
I've been
to.
using.
You have to. Yeah, random what?
Import random forest classifier.
Good. Random forest classifier. It's an ensemble algorithm. So what do we do? Initialize it, right? So let's just call it model. Yeah. So we fit, right? Model dot fit. What did you pass inside the fit? You pass all the train. You pass X train and Y train. Yes or yes?
Yes.
Yes.
Money. The model has gone to school to learn. He has learned. So once he lands, what do you do then? You predict, right? Yes or yes?
Yes.
Y
Yes.
predict is equal to model dot predict.
Predict.
What are you passing?
X test.
X test.
X test.
Y test.
No, to predict. Yes, are you sleeping?
X test.
So we predicted. Okay. So after you predict, what do you do
Yes.
next? Score. High performance, right?
Happy Ziggy.
Score is equals to model dot score. So what do you pass into it to score it? Yeah.
Y test.
Y test and what?
Y test.
And what? It cannot be only Y test now. Y test and what? Blessing, where are you? You want to score your model. This is what we did last week. You've done it. Let me raise it up for you to see. When we did regression. So you don't know this. All these things are important when we did the prediction. We
No,
did
we know it all.
score. When we score, did you score the model? No, we didn't score this one. There's one we score. Score. You see what you score? Can you see? Can you see?
Yes.
Can you see? So,
Yes.
so blessing.
Yes.
Maybe she's having network. Okay.
It's not network. When it's easier, I can agree. Not blessing. There's nothing like
Abi
network.
Mag.
You
Abi Mag.
are a regular no network now.
Baba,
Yeah.
network that is not made in Nigeria.
Nobody
So-
reached me for network wahala.
In fact, today is even surprising that since we started the class, you are still available. So
Honestly, even myself, I'm surprised.
the model is at 98. You see? So this is
Did
better.
not do well.
98 did not do well.
Like our own.
Which one is your own? Your own that is one.
No, I feel like
Hmm.
this one tried because when the one I did before, when I did my own without this imbalancing, it was giving majority was one.
You know what I told you? I said that's what I said. That was the essence of this model now. This one now, even if it's giving you 98 is even very good, and it has the ability of predicting the two. The one you did one is only predicting one. A blessing. So your model is performing, but it's performing beautifully nonsense. Sorry to use that language because it's only seeing one out of two things that you need to see. But this one now, even at 98, is seeing the two. Okay? Aha. Blah blah.
Yes.
Yes, sir.
Do you understand it now?
Yeah.
So you see the improvement you have done. This model now will predict the two classes equally. No bias. Okay? Based on whatever it is you give to it. But what you did initially, we only see more of one. Even when the cases should have been zero, your model will be seeing one. And that is not what you want to do. Okay? This is an improved version of what you have done in your assignment. Okay? So going forward, don't just jump to build model. If I give a classification problem to solve, don't jump and build model. This thing is to. So this is
So
like what?
is it just for classification problem?
Yes, it's only I said it's only classification that you have imbalance for. Regression is just direct. Yeah, that you're not doing any classification, any imbalance for regression. Okay.
Okay.
Any question?
Yes. No?
That's it. So out of 4, you see what we have done now. So when we get to, we've done random, under sampling. Out of 4, we just did 1. So the same thing is what The same thing is what did you say? We say something.
No.
Okay.
Sorry.
Every other thing will also follow the same thing. Okay, so we're going to see it, but it's very pretty simple. So we're not going to all this I've explained to you now. But I want to do under oversampling, I will just pick and I'm gone. So the only thing is that when you're done your sampling for oversampling, your output will be more to the highest part. So what you're going to be seeing is 20,000. You see the difference? On like 400 in this case, okay? So that's how it's going to be. And you do the same thing that we have done, and you get your final prediction. Then when you do smooth, the same thing will happen. When you do smooth EM, so it's not going to be an assignment. You're going to see each of those four so that you understand at what point. So this model now is pretty good. This is improvement of what you did initially. Because if you go and give your client that one you did initially, every time by the time they are using your model, what they're going to be seeing is there is flood. There is flood. Even when it's a dry season, your model will say there is flood. The question is, where did you get the rain that gave you flood? Okay, so you have to understand. But this one now studies the two and it balances it. You can see the balancing. So you don't need anybody to tell you that by the time somebody is going through your know, you already know what you have done. Oh, this is the balanced data. And in real life, data will not be balanced. Okay? Don't be surprised because you're not the one that collected the data. So there is need for you to always balance your data set, especially for classification problems. Okay, you can play around so many things. You can build your model like a checkmate model even before you do balancing. And when you do balancing, you see the model again. You predict, use the input or your test data to predict and see what you are going to be having. Imagine if you have a data set like text data externally, and we put it in your model you did yesterday, and you did that as an assignment to predict. We are going to be seeing more of one. But when we use the same test data and put it on this model now, it will balance it. You will see one, you see zero. It's not going to be biased towards one side. You get the idea now, which is improvement. Is that clear? Is that
Yes.
clear? All right, good. So this is where we stop today. So for the model optimize, all these things we are doing now is model. You are optimizing your model. You are seeing how you can. Please take note. They are very important. Okay. Any question?
Yes.
Any question?
None from me.
Blessing. Any question?
No question.
Is there any question?
Mba.
All right, good. So now listen to the assignment. Give me 5 minutes more to explain the assignment to you. For this class, there's no assignment on this project now because we are not done yet. I want to show you the four. When we're done with the four, then project assignment can come. But the assignment we're going to do today in the next week is I'm going to give you guys a three. We're going to be working with 21 algorithms. How many do I say?
Is it
21
again?
algorithms. 21, 21. We're going to be working with 21 algorithms. These 21 algorithms has regression algorithm and also classification algorithms. For example, logistic regression is a classification algorithm. Yes or no? Yes or no?
Yes.
Why linear regression is a regression algorithm? Yes or
Continue.
no? Continuous, yes. Continuous algorithm. Yes or no?
Yes.
Good. So
Yes.
what I'm going to be giving to you is, now listen, is 21 algorithms. These 21 algorithms will comprise of the two. That means regression problem, classification problem. Each of you will work on 7. That means 7 by 3 is 21. Now, this 7, let's say I'm giving Mark 7 algorithms that will comprise of both regression and classification. What is your assignment? Your assignment is number one, on your 7 algorithm that I'm going to be assigning to you is we are going to come up with a write-up on each of the algorithm. So you are writing a write-up. You're going to present it on each algorithms that I give to you. What are the write-ups? What are you looking at in the write-up? When, but how do we use it? When do we use it? Okay, so this write-up will include what is, when, and how are they used. So that's one. Two, you define the hyperparameters in each algorithm that you are given. Number three, you will define the code to instantiate it, each model, each algorithm. The fourth one, advantage and disadvantage, advantages. Yep. Yep. I think there are 5 questions. I don't remember the fifth one. You will write up on what is, for example, what's a logistic regression? Tell us, when do we use logistic regression? How do we use it? That is one. The other part is define the upper parameter. What are the upper parameters of a logistic regression? You list it. Maybe there is alpha, maybe there is gamma, maybe, so you define what is an alpha. Alpha in logistic regression means maybe there is number of estimator. What does it mean? You define each of those upper parameters of logistic regression as an example. The next thing is you define the code to instantiate, okay, from sklearn, dosky, whatever, import, blah, then instantiate it. That's all you need. Put in the upper parameters if you want. The advantages and disadvantages, maybe at least 2. You should tell us at least 2 of each. At least 2. Okay? 2 advantages and 2 disadvantages. Then what other fifth one? So this is going to be your assignment. And why this is important is, let me explain to you. All the 21 algorithms, we are going to use them. Okay? Are you there?
Yes, I'm here.
All the 21 algorithms, we are going to use them in class. Now, what's going to be the implication is that if you take your time to do this assignment and you're able to know 7, so that means that at your own fingertips, you already know 7 different algorithms that can be used for linear regression problem and classification problem. Maybe 3, 4, or 4, 3, depending on how I do the shovel. Now, that's one. Secondly, you will understand that 7 because it's your assignment. You will do due diligence on understanding everything I've written. If you can put those ones in your head, anytime, any day, you are confident at speaking on these 7 algorithms because you know them. You know how there's no how they want to play around it, you know them. Now, when you're able to do your own, by the time all of you submit, I am now going to make a compile list of all the findings you made and we share with all of you. So already you have worked on your own 7 with your full due diligence. Another person has also done the same thing. So even if you don't have time to check the remaining 14, somebody else has done it for you, you join in with what you have learned, which is your own. So at any point in time, you can always check. It's okay. And by the time you do those things, you get yourself familiar with the other 14. Already, before you know it, you will have learned 21 algorithms that you can use to solve either regression or classification problems. And that is good. And you know when to use what. You don't just pick algorithm because you are finding you have it in the internet. You just know. You know why you are using what you are using. And when it comes to hyperparameters, why this is important, because after we finish this thing, the next thing you'll be going to is hyperparameter tuning. So this is important. This assignment must be completed before we go to that class. So by the time you start it, I'll just call any of you in class. Which algorithm are we using? Part of the one you have worked on. Tell us why should we use it? Why is it important on this data? You justify those things. So those things will help you to know more on all of this algorithm. So that's why this assignment is important. That's why I'm not going to add anything to do. That is your main assignment. So you're going to put them on in Word document, type everything that you find. Google is your friend. Everything is in the internet. Check it, read it, put what you think is. That's why I'm not adding more information. Just fact on each of those things. And you put them together, you know them. At least you have your 7. You are the custodian of that 7 that I'm going to be assigning to you. You can boast of it at any time. Plus, all other students have also helped you to do other 7, which is 14. So automatically, you had 21. So, and I'm going to be calling on all of you by the time we start that process or that class. I just mentioned, Mag, out of your algorithm, which one do you want us to use? Why are we using it? Why do you think it's the right thing? So you're going to be speaking from what you have learned. So that will be your assignment. Hope it's clear.
Yeah, it's very clear.
So do you have any question on it? Mag base.
No, I don't.
Is it clear?
Very clear.
All right. So blessing. Stop sharing. Blessing. Let me stop.
Yes.
Yeah. Do you understand what I said?